angle of reflection. There is a small flaw to this plan of mine, is that the simulation I found is actually wrong. Don't tell anyone, you'll have to use your brains to make it right. So we know, first of all, that this white line is representing a mirror, and it's a flat mirror or a plane mirror. When you have a light source, like this green ray of light coming that way, shooting straight at the mirror, it bounces straight off again, and we know that as well. Problem is this protractor. So the protractor is set to have 90 degrees shooting straight out, which it does, but in light we always measure from that angle. So that angle is actually 0 degrees for us, and we call it the normal line. So here's my normal line continuing through. We can actually see what happens when we change the angle. If it came in at 10 degrees, let's see if I can get 10 degrees to pop up. 10 degrees, let's pop. There we go. Which is, it says 80, but it's actually 10 degrees. So it comes in an angle of incidence at 10 degrees. The angle from normal to the angle of incidence is 10 degrees, and the angle of reflection is 10 degrees as well. If we go to the next one, here we go, it says 60, but it's not 60, it's 30 degrees. So the angle of incidence is measured from normal to here, that's 30 degrees, and it reflects at 30 degrees as well. What else we got? We've got this one at 45 degrees. Well, this one is right, because it's 45 degrees from here to here, and it's 45 degrees from here to here. So angle of incidence is equal to angle of reflection. What else we got? We've got 30 degrees. Well, 30 degrees isn't 30 degrees at all, it's 60 degrees. So we measure from normal to the angle of incidence, 60 degrees, and then move from normal to the angle of, or the ray of reflection. It's not the angle of reflection, we're measuring the angle of reflection is 60 degrees. We could do it with 10 degrees, which is actually 80 degrees. We could do it 15 degrees, which is 75 degrees. We could do it at 5, which is actually 95. No, it's not. It's 85 degrees. We can do it at 0. So if the ray of light comes exactly along the front of the mirror, well, it doesn't really bounce, does it? But we could pretend it did. If it comes in at 90 degrees, it comes out at 90 degrees as well. I hope that helps a little bit, at least. Take care, and cheerio. I'm going to find my pausing button now, if that's possible. I can't find it. It's gone. Pause.